Okay, so we are going to go over 2.3, 16, 19, and then 22. So starting with 16, it says, given g of x is equal to log base 5 of 3x plus 2, select all of the functions that are equivalent. For each function that you selected, explain why it is equivalent. So this is a very classic Miss Johnson question, right? Like you can plug these all into the calculator to figure out which ones are true, but then it asks you to explain why it's true. Okay, so any preference on which one you want to see done first, A, B, C, or D? Any of them? Okay, so someone said D. So I assume that this is the craziest one, and it's actually very tiny. So let me make it bigger. Okay, so it says log base 5 of 50 plus log base 5 of 36x minus log base 5 of 4 minus log base 5 of 3 minus log base 5 of 2. Like, what are you talking about? Okay, so the very first thing that I want to do is, man, this is a really long, like it's a long one. So I'm going to remind you about the properties that we talked about, right? And one of the properties basically said, and I'll write it over here, maybe up here, actually, let's write it right up here. So it's log, oops, I'm writing in highlighter. So log base, I don't know, base b of x, y, x times y to be specific, is equal to log base b of x plus log base b of y. And we said this, we likened this to when we're multiplying bases that are the same and they have exponents, right? So when it's multiplying, then we add over here, right? So because I see adding here, it's kind of making me want to multiply them, right? And then when I have subtraction, if I have log base b of x minus log base b of y, what is happening over here? What's happening inside this parentheses here? Oh, it's going to take its time. It's actually division, right? So that's x over y, or x divided by y. So all of these minus signs here, boom, 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 they're just reminding me like, hey, I'm going to be dividing. So this is a pretty big log problem. So I'm going to write log pretty big. I'm going to go like this, log base 5. And the first thing I want to check is to make sure that all the bases of the logs are exactly the same. Base 5, base 5, base 5, base 5, base 5. Sweet. Thank you so much. I appreciate that, hon. Bye. Okay, so then the next part is, okay, so because this is multiplication here, right? Because I'm adding the logs here, that means inside my log, I'm going to be multiplying. So I'm going to go like this, and I'm going to go 50 times 36x. And now this number is really big. I don't really care that that number is really big. I just know that now I'm dealing with something that's a little bit more doable, because I don't know what the log base 5 of 50 is off the top of my head. I mean, I know it's somewhere between 2 and 3, but that's not good enough for here, right? Okay, so then all of these minus this, minus this, minus this means that I'm going to be dividing. Now, don't confuse yourself, okay? So if it's dividing, it just means each of these are just going to belong in the denominator, right? Don't think, oh, and then I have to divide that by the dividing of, no, don't make it more complicated than it is. So this just means I'm going to put a 4 on the bottom, a 3 on the bottom, and a 2 on the bottom. Now, Ms. Johnson, why did you put times in between? Because in the operation of division, when you have numbers that are kind of like 36x, if 36x was on the bottom, there's a multiplication, an invisible multiplication sign there. So the same thing goes here. So let's see. Select all the functions that are equivalent to this thing here. Okay. I don't know. It doesn't look like it yet. So I'm just going to play with this a little bit to see if there's anything that I could do. So is there anything that you could do inside this parentheses? Ignore the log base 5 for real quick. Is there anything that you can do right here? Yeah, we can start multiplying or dividing out. And so my preference is never to make numbers bigger. My preference is always to make numbers smaller, right? So I already know that 36 and 4 have a common factor, and that's 9. So I'm going to divide 36 by 4 and leave me with a 9. Got it? Yeah, you can definitely multiply 50 by 36. I don't know what that number is, nor do I want to know right now. My tendency, my strategy is always making numbers smaller before I have to make them bigger. And because division and multiplication are, as long as you do it from left to right, you're fine. Okay, so then same thing goes, yeah, so now it would be 9x, right? But then I can also take this 9 and divide it by 3, right? I could take this 9 and divide it by 3, leaving me with 3. And is there anything else that I could do inside this parentheses before I kind of like leave that? Is there anything else that I can simplify? Yeah, absolutely, hon. So I can divide 50 by 2, right? I could divide this 50 by 2, right? So 50 divided by 2 is just 25. And my brain goes, oh, I know what's going to happen, right? Because that 25 is so, I don't know if this makes sense, but it fits so well with my log base 5, right? So let me clean this up just a little bit, just so that it's a little bit more neat to look at. So here I get, I still have my log base 5. But now I have, and I'm going to leave it as 25 times 3x. I like that. I like my 25 times my 3x. I don't want to write, I know what 25 times 3 is. It's 75. I don't want to write it like that because my log base 5 works so well together with that 25. Log base 5 of 25. I know what that is, right? So if you notice here, I'm going to use that property again, right? When it's multiplication, you can't really see it. Let me make it tinier. When it's multiplication over here, like it is right here, 25 times 3x, then I can make it an addition statement instead. So I'm going to copy that again. So I got log base 5 of something plus log base 5 of something else, right? And so when it's multiplication here, then I can kind of like rewrite it in terms of adding logs, right? So you should know that 25 goes in here and 3x goes in here. Which if you look, again, my whole goal is to see if it is equivalent to this. And I'm like, oh my gosh, look, I have log base 5 of 3x. It's almost there. So, and you know what log base 5 of 25 is. What's log base 5 of 25? Wait, log base 5 of 25. So 5 to the what gives me 25? 5 to the what gives me 25? Yeah, it's 2. So remember, I just make this big 2 right here because it's fun, right? So that says 2 plus log base 5 of 3x. So I'm just going to write that out and then I'm done. 2 plus log base 5 of 3x. Right? But Ms. Johnson, yours, this one says log base 5 of 3x plus 2. Yeah, it's okay to switch, flip-flop those, right? Because the commutative property says 2 plus 5, let's pretend this is a big O 5. 2 plus 5 is the same thing as 5 plus 2, right? This is not equal to 5. I'm just pretending. So yeah, this one is actually one of them. D works. Is there another one that you wanted me to check, or was D the only one that was like, ugh? Is there another one of these? Okay, good. So C, let's do C together. Yeah, I could see why C is annoying. C looks annoying because of this this square root business, right? So again, I'm going to follow these rules. These are the rules that Miss Johnson gave me. She did give me one more rule or property today. I'll write it out as well. It's the power rule, and it was log base b of, I think they used k, x to the k is equal to k times log base b of x, right? And so this was the power rule. Remember, and we talked about when we had powers, they would multiply the exponents. So same thing goes here, right? All right, so let's do this part here. It says c of x is equal to all this minus this plus this plus this. So again, I'm going to do the same thing that I did here. I'm going to make a big old log, and I'm going to put everybody who's adding on top and everybody who's subtracting on the bottom. I'm also going to figure out what the heck square root of 625 is. By the way, I know what it is. I'm just saying. So I want to see if the square root of 625 is something special or significant, because then that might help me. So there's 625. I take the square root of it. It's 25. We like us some 25s, right? When it's log base 5, we like that. Yeah, I'm so sorry. Let me just say this. These two, I didn't make it very, very clear, but these two right here are exactly equivalent. Equivalent means the same, right? These two are equivalent because look, when I simplified this, the answer looked like this, right? So remember that equivalent means like has the same value. So like, for example, a $20 bill and two tens, right? Those are equivalent. So if you show like a little human, remember I told you this before, if you show a little human like a second grader or third, no, maybe not. Oh, no problem, honey, I figured. If you show like maybe a 3 or 4-year-old and you're like, hey, are these two things equivalent? And you're holding a $20 bill and two $10 bills in the other hand, like they would be like, no, those aren't equivalent, obviously, because this one has two of something, right? And you trip them up even more if you give them like 7 $1 bills and a $20 bill, right? Because in your head, you're like, obviously it's the 20, but to them, it's like, no, this is more, right? So even though they look different, this crazy d of x function and this guy right here, they look completely different. This is like the $1 bills. Maybe this is even coins, right? Maybe this is quarters and dimes and nickels and pennies or something like that. Of $20, right? And then this is a $20 bill. These look way different, but the value is in fact the same. Okay, that's what we want to think. Okay, so this guy right here is just the number 25. So I'm going to remind myself, this is just the number 25 right here. You're not fooling me. And we really like when we have powers of 5, because when we have powers of 5, we know what to do with them, right? So this right here, I already know is just the number 2, right? It's just the number 2. And Miss Johnson, she just writes the number 2 like that to remind you, this is just 2. Oh, you can't see what I'm doing. Hold on a second. Okay, that's the number 2. So here, I'm just going to make a big log just like I did before. Everybody's added is going to be on top. Everybody who's subtracted is going to go on the bottom. So let me do that really quick. So I got my big old log base 5, which reminds me, shoot, I need to make sure that all of these have the same bases. Let's see. Log base 5, check. Log base 5, check. Log base 5, check. Log base. Oh, they're all log base 5, Miss Johnson. Oh, wait a second. We know this guy. We know this guy. Log base 5 of 1. We talked about this the last time. No problem, honey. I think so. I just need to get them done. Yeah. What? Yeah. Log base 501 is just zeros. Oh, okay. So I can just write a 0 here. So now I don't even need to worry about him. I'm just worried about these 3 now. I'm not really worried, but now I'm dealing with, right? So log base 5 of 9x. So now let me put that guy on the top. That's 9x is on the top. I got to divided by 3 because that 3 is minus, right? It's a minus log base 5 of 3. Now don't mess this up, okay? This whole thing is equivalent to 2. This whole thing is equivalent to 2. So I'm not going to put the 2 up here. I'm going to take the 2 completely on the outside plus 2. And that's going to be my 2 here. This 2 here is that 2 there, right? This 2 is that 2. And Ms. Johnson, do you want me to write the +0? No, you wouldn't write a +0. If you wrote the number 10, you wouldn't be like 10 + 0. No, you would just write 10. Okay, so then does anybody see anything that I could do here that I can simplify? Because again, my goal is to make it look like this. My goal is to make it look like this. Anybody see anything? Yeah, divide. Ms. Johnson, 9x divided by 3x is just 3x's. And then plus that 2, exactly. Okay, I keep writing parentheses around my 3x. Technically, I don't have to. Okay, it is understood that this term belongs inside or with the log base 5. Okay, belongs inside or with the log base 5. But Ms. Johnson, the +2 doesn't belong in there? No, because the +2 is like, it's outside of it. So that's why if you ever notice how I write it, I won't usually write it like this because it confuses people. I'll write it very obviously so that it says 2 plus log base, 5 of 3x. So if you're ever confused, does it belong with it or not? You can always use a calculator to verify what you're thinking and see if that's what you wanted it to be. Okay. Did you need me to go over A or B? Or are you okay with A or B and B? Okay. Let me know. Okay. So the next number we're doing is number 19. This guy here. These crazy little exponents, right? Okay, so what they want you to do, so first of all, this is true, right? Okay, just know that. Yeah. Oh, C. Was C an answer? You tell me, looking at this and this, are they equivalent? Yeah, it is. Because it's exactly the same. Yeah, right? Because it says log base 5 of 3x, log base 5 of 3x plus 2, plus 2, plus 2. Done. Yeah. Okay. So for this one, first of all, is it true? The answer is yes, it's true. And then they want you to convert this to log form. Okay. They want you to convert this to log form. So whenever you're converting to log form, you're going to write log. And I tend to write my logs really big. So it's obvious that my base is a base. It's a subscript. Right? Okay. So then log of, what's my base going to be? Is my base 2/3 or is it 3/2? Yeah, this case, it's 2/3. So your base is always going to be the base with the exponent, right? Your base is always going to be the base with the exponent. So since this guy had an exponent, then that's your base. Got it? Okay, now what's my argument? What goes here? And then what goes on this side? What goes here? Yeah, 3/2 goes here. My argument is the answer. People tend to say it like that. The argument is the answer. And see how they both start with A's? It's like alliteration, right? Argument, answer. Oh, sorry, argument, answer. And this guy over here is your exponent. Equals to -1. Right? So that -1 goes there, but it's catching up to me. So that makes sense. Does that help you? Is that good? Yeah. It's like, this one is funny because it has fractions, but if you stick to the definition of what a log is, then it makes sense. Yeah. Yes, I'll go back and get that one done too. Let's see. And then the last one is number 22. Again, fractions, right? So I just want you to be comfortable with the idea of, okay, I need to switch these out, right? So if if this is log base 2/5 of 825 is equal to 3, what is the base over here? What is the base? Yeah, it's 2/5. So I make a really big 2/5. Now here's the thing with fractional bases, okay? If your base is a fraction, I always use parentheses. If you don't, then it's wrong. I'll explain why in a second. Okay, so then let's write the rest of it. So then what would my exponent be and what would my answer be? What's my exponent? What's my answer? What's the exponent? What's the exponent? What goes right here? Yeah, the exponent is 3. So notice how, like, look up here. See, look at my exponent up here. Comes from the log's answer, right? So here, right? So that makes sense. Choose the same color, right? So then what goes here? What goes here? What's the answer over here? Yeah, very good. So notice here, this guy here is this guy here. Your base is always going to be the base. See, log base 2/5. This is the base. So your base is always going to be the same. These are the two that are going to flip-flop. That's what my brain says. Like, okay, then because you're saying 2/5 to the what gives me 8 over 125, right? Okay, so I told you that I wanted to show you why these parentheses matter. And I think the easiest way for me to show you is by using a graph. I mean, not a graph, but Desmos. So if I did 2/5 to the third, okay, look at that answer, versus parentheses 2 divided by 5 to the third. Oops, that's not what I wanted it. Sorry, I wanted it like that, to the third. Do you see how different these are? So this says to the third. And even if you did the other way, if you did 2 to the third, then divided by 5, see, these answers are all different. Okay, and here's why. For this one, who's being cubed? For this one, who is being cubed? And for this one, who is being cubed? So for this one, only the 5 is being cubed. For this one, only the 2 is being cubed. But for this one, it's 2/5 is being cubed. That's why your answers are all different. So do you see why it matters when I say make sure your answer is in parentheses? Yeah. So this is what I mean by use your calculator to your advantage, because that's what it's for. It's a tool. It's a tool for you to verify that you're right. Yeah, include the entire fraction. So if you had written it like this, it would kind of show up like this, right? Like this guy right here, 2, and then to the third, and you have like a divided by 5th. Just imagine these parentheses gone. This is what my brain actually thinks. This is what the calculator is going to calculate, and it's not correct, right? Okay, last question. Someone asked for numero uno, this one right here, right? So this one said rewrite the following expressions with an exponent instead of a radical. So this is like, remember back in the day when we were first talking about radicals, and this is, again, just a review. So it says, this is, just know, oops, sorry. This is x to the 1/5. Okay, when you're writing exponents with radicals, this guy right here, I think his name is an index. This index here is a 5. So this index here, 5, matches with this denominator as an exponent here. This exponent here, this index here matches with the denominator of the exponent. Yeah. Okay, so with that being said, right, how would you do this one? So they just want you to rewrite it with exponents instead of a radical. So you would just take that whole thing inside, right? 8x squared. They don't want you to do anything with it, right? And then they want you to take it to a power. So what's the power for a cube root? Yeah, very good. 1/3. Very good. 1/3. That's exactly right. Good job. Make sense? Any other questions?